Thank you,
thank you, thank you, thank you.
I'll stand while he speaks.
Thanks very much for coming this morning, especially after World of Wine last night. It was a fantastic event. I know Shareef and myself really looking forward to the showcase. And why are we looking forward to the showcase? Well, we sell vehicles that have so many of your technologies in there. And they will always have so many of the different technologies in there, from COVESA, from proprietary pieces of the stack that are put on top of that. We integrate all of that through the tier ones, through the silicon vendors. That's what Shareef's team does, in order to get to that next level, which is the cool car that Mattis almost ran out of electricity in on his way from Cologne. So today we're going to talk about some of the future challenges that we might have in OEMs. Shareef will interrupt me. This is how we operate at Ford on a daily basis. Fair to say?
I'll try to.
It's true.
Do my best to
And I get him back, though. It's okay. And my role at Ford is future strategy for all of the technology. So this is all the different horizontals that you might have that run across vehicle programs. Everything from a cell to an e-drive to a rear heated mirror, right the way through to the next infotainment to electrical architecture. And as well as that, I look after research and advanced engineering for all those different areas. And Shareef?
Well, I try to drive at least advanced platforms and simulations. So looking at simulation frameworks for Ford that's going to use to be developed for software. And I'm actually the chief system architect for future architecture for Ford. And we work closely, my team works very closely with Matt's team and other teams in order to developing top of the stack software applications and SDKs that are released relying on VSS and other specifications that we do. So.
Yep. So in a description, I think about, with you and with your teams, what do we need in the future for really cool vehicles? And yes. Shareef gets pregnant with delivering it.
We try to, yes.
Yeah. And some of the challenges that we have from a Ford perspective, if we think of the start, we're going through this huge revolution that we call Ford Plus, that is about EVs as well as the existing ICE vehicles. And quite a few people tend to think that's binary. You've either got an electric vehicle or you've got a gas-guzzling ICE vehicle. And that's not the case. So in the US or in Europe at the moment, if you look at it, we have these partial hybrids. So in reality, it's an electric drivetrain, an intermediate battery, as well as a different source of energy. And as we go through the next 10 years at Ford, at least, we really believe that there's going to be more and more of this continuum when you might have plug-in charging, you might have existing ICE engines generating the electricity, you might have existing ICE engines connected directly to the wheels. Or, as public knowledge, we're working on fuel cell technology, having a hydrogen tank, a fuel cell stack, generating electricity to then go into a small battery to power the vehicle. And we're working on that with COVESA members. In the case of fuel cells, Bosch presenting next. In the case of the ICE engines, we've worked with all of these different active control systems, all of these different members in different areas of the vehicle. And that's important because as well as our kind of focus of increasing the different systems, or the different number of systems that we have going forwards, we're working as part of an ecosystem to solve customer challenges. I showed this one in Dearborn. Actually, I think Lisa Drake did in Dearborn. If we'd have asked people what they wanted, they'd have said faster horses. I've been using that quote for years, but now it's even easier that I'm at Ford, and Henry said it.
As a tool developer, frankly, this is one of my favorite quotes. I've been using it also for years. So this is a guiding principle for many of the things we do today. So.
But sometimes we relate that in Ford terms to the wrong thing. We think that the guiding principle is about the underpinning operating system. And many of you have heard both of us say nobody ever bought a car for an operating system. We buy it for the features at the top, and how can we make everything else the minimum viable setup that we need to deliver those amazing features to the customer. And in reality, our customers have, just like you have on your iPhone, a whole host of different applications. It was good to hear Steve talk about FMS and the commercial vehicles. That is key to Ford. Our users our customers, everything from police vehicles to refrigeration vans to cherry pickers to F-450 Super Duties that can tow 40,000 pounds, 18 tons across the US. With all this ecosystem of upfitters that could be everything from a snowplow to an armed bank on the back of the truck, so much stuff.
It's a wide range of use cases that we can't even know all of it, right? When it comes to upfitting world and how customers are going to be treating our vehicles or working with them is something that there are a set of use cases we can think of: snowplowers, cherry pickers, whatnot. But there's also a huge set of use cases that we really don't know how it's going to look like in the future, right? We know that we need to support it. That we do.
No, I'm just seeing that we've got an issue with the PowerPoint. It looks like it's been copied into the deck without the formatting. So this isn't going to be readable. I'd actually propose that we maybe step back for 3 minutes. It's not going to work on some of these slides, unfortunately. I'm so sorry. So we'll do entertainment and questions from the audience on a picture.
Can you go back to the previous slide, actually, for a minute? The one with the phone, right? Because I think there's a good point, the one with the iPhone you had there.
Yeah.
So there's actually a good point here, right? That our customers are also looking at our vehicles more and more like phones, and that's what they're expecting. And the expectation, we talked about it yesterday, Matt, that you brought it actually, there's an expectation here of 24-hour turnaround time for fixing bugs. 24 hours turnaround time for new experiences, having new applications in the phone, right? Which is, people are wanting to see more and more in vehicles, and we need to deliver that. So we're talking about huge reduction in turnaround time, and we're building our vehicle not in a point that, okay, it has to go from point A to point B only, but it has to support these user experiences and provide them all the time in a very fast turnaround time. So
but that's not just the software. If I think of Apple would literally take their latest M2 processor, qualified to go into a phone, and try and get it onto an Apple Store shelf within 6 weeks. Not saying that we're doing that, but wouldn't it be cool in the future if automotive could almost get that latest silicon into the vehicles as well? Or some way from that.
And we'll talk about that in the next slides.
We will, hopefully. But you know we're filling at this point in time. Thanks. Thanks for your... When it comes to all of these different use cases, it's exactly the same. So here, if we've got an engine being loaded onto the back of a truck, the challenge that we have with all of our partners, not just the typical auto ecosystem, is they want to be able to use the controls from within their infotainment system. They want to be able to use that integrated environment that Ford would provide in any of our vehicles. That means that we need an API that we can give to all of these different cherry picker manufacturers, all these different refrigeration manufacturers, and say, this is how you interface to a Ford vehicle. And from their perspective, they don't just go into Fords. They might go into Mercedes Sprinter vans, all of these other commercial vehicles out there. And we at Ford, and they as the upfitters, want a standard language so that what they're doing appears not only in the vehicle, but they can get data back about how their upfits, how their things are being used from all of the different OEMs, all of the different vehicles in a common way. So think about it, again, going back to the app. If I deliver an application across 14 different versions of iOS and on 6 different versions of Android, I wouldn't dream that I got all the data back from those 20 different versions in a different way. Why would it be any different with a cherry picker on the back of a truck from a Ford perspective?
Yeah, you're absolutely right. And I think if we think about fleet owners, for an example, they have a wide range of vehicles, right? It's not only one vehicle. They don't only get the latest and greatest Super Duty. They have older Super Duties. They have F-150s. They have Transits. And they do expect their upfitting capabilities to run the same on all of them. They want their software to be able to migrate from one platform to another platform, and based on the capabilities of that platform to execute their use cases. But they do want to have that generic software approach for all of these different vehicles.
No, that's it. We've totally dried up now. We're screwed.
We can sing.
Should we talk about brandy again?
You had that GPT song yesterday. Maybe we can do that.
Oh, no, that was Paul. Apparently he didn't sing the song, but that's okay.
Let's keep going, I think.
Do you feel up to trying to?
I think we covered most of this one, right?
Okay.
So, yeah, let's jump to this.
So where we are within Ford at this point, we're looking effectively at how all of these different EV systems integrate together. And you can see this guy has not, at this point, got his hands on the wheel. How can we integrate those into semi-autonomous L2 systems? Hands-off, eyes-on systems. But again, what does that mean for all of the different things they could be doing instead? And how does that come in, just as I shared yesterday, with that continuous expansion of this connected ecosystem? At Ford, we are working with the EU commissions, we're working with the federal government, we're working in Australia on a number of different initiatives. One of the biggest is Cellular V2X. Cellular V2X, announced by the US FCC, has now been given a deviation for 5.9 gigahertz. It is coming. Ford have made public announcements about that previously. We like Cellular V2X not because it's 5G, 5.9 gigahertz, but because it allows us another communication bearer to go between vehicle to vehicle and vehicle to infrastructure. And we see that as critically important going forwards. But at the same point, as well as it being critically important for what we're doing, it's challenging for our engineers, it's challenging for the testing that we have going forwards. And if you think of the amount of API that we might have across VSS and the system at this point, it's going to only increase as we bring everything into that ecosystem. And Ford would collaborate, but at the same point challenge our partners in COVESA. What should we do next? How should we make it easy to expand an interface to these different domains without causing an overhead? And just as I kind of shared verbally yesterday, Shareef and my biggest challenge, we talk 99% of the time about the product. But we have 19,000 people within Model E, the electrification business, that we support, and we have to help them through a mindset change. And it's not just the mindset change of electrification or connectivity, it's the mindset change on the speed and the software-centric nature of this going forwards.
Yeah, it's taking a company into modern software practices, into into new capabilities, and the mindset of that vehicle is a living entity, that things change, things evolve, and the new user experiences are deployed to our users. We fix bugs, we deploy it, and we move on. And that's the mindset change that we all are going through. All right, here it works. But you gave it to me because it doesn't work. All right. We've talked about this
That's
many
just
times.
The project, Shareef. It's not the clicker.
That's I'm used to. So we've talked about this multiple times, right? We're not talking about vehicles only, right? We're talking about a huge ecosystem of devices that communicate through a cloud entity. Through edge nodes, right? And that's the complexity we're talking about. This is the ecosystem. That's where the problem statement lies and what we need to work with. Some of the challenges that we mentioned, and we'll mention it again because it's actually very important as it adds layers of complexity, is we're talking about many end data points and many vehicles that communicate through multi-tier programs that is fragmented and siloed. And for us to be, not only us as OEMs, but also customers, developers, tier one suppliers, for this to be able to adapt correctly, we will need to have some kind of order there. And we do see that VSS brings that consistency amongst the different endpoints, vehicles on one side, and data points and data usage on the other side. Some of the key transformation pillars, and I think this is important, that are driving us in these challenges that we just talked about. The first one is having modern tools, laws, and methods to support this transformation, which is very important. If we are going through a transformation, if we're going more to be a software-oriented company, if we're going to do OTAs all the time, then we need to have the tools to support that. And we cannot rely on tools that are before this era, right? And we have to be all the time on top of what's happening on the market, what's new there, and use it. The second one, which is a very long debate, is modern software practices, right? How do you write software in a way that it can be agile, it can be deployed, can be changed, it can be debugged very fast, it can be understood, so the complexity of the code is very low. And how do you measure that? Not only how do you write that, so how do you put systems in place that can tell you for every check-in that, okay, this is good or this is bad. You have the right coverage, you don't have the right coverage. You have the right complexity or you don't have the right complexity.
But also, the software that we put into the embedded systems, it has to be certified.
That's another layer of complexity that's added on top of it, right? So you need to have it good and certified. And that's different, actually, than other markets. The third point is, it's like we know what we know today, and we know that in the future, there are many unknowns, okay, that we can't really tell today what's going to be. But we need to build platforms that enable us to adapt to this need that is vague at this point, right? We don't know fully what users are going to want in their car in 5 years. And keep in mind that when somebody buys a car, when a fleet owner buys a Super Duty, they don't expect to change that every year. That's a vehicle that is with them for 3, 4, or 5 years. And we want to be able to build experiences that change along this time. If there's something new that's happening, something that's appealing, I want to be able to deploy it to that vehicle. For me to be able to be successful as an OEM, I have to build platforms that support such an increasing need and changing.
And that's really critical. If we think the average lifespan of a commercial vehicle, best-selling vehicle in Europe is actually the Ford Transit, it's like 11 years. And through that 11 years, it might start off as an Amazon parcel delivery and then be bought and be fitted out with shelves for a plumber, and then have the back chopped off it for somebody to use to haul sand across Europe. There's all of these different use cases that you go through the vehicle life. It's not unusual for a police vehicle to be sold off, all the police equipment to be stripped out and used as something completely different. And that's the challenge that we have, and it's software-centric as well as, or as much as anything else.
Fourth bullet is agile mindset. And it's not about the Scrum or Kanban that you run in your teams, right? It's about being fast, being agile, being able to adapt to changes and needs quickly. So there's a bug, those happen, not as much, but those happen. You need to be able to identify it, debug it, fix it, test it, and deploy it. That cycle has to be very fast. It can't be a multi-year journey. It can't be a multi-month journey. The phone example is a 24-hour journey, right? So we want to be somewhere there. What do you say?
I think we have to. Can we do a show of hands for the audience?
Yeah, let's do that.
Okay, this is a fun one. It's 2030. You have a connected, autonomous electric vehicle on your driveway that does full L3. Suddenly, there's a cybersecurity vulnerability from an operating system vendor on the network stack. Think something like Urgent 11. At which point you know that that vehicle has a cybersecurity vulnerability that has invalidated the safety certification. How quickly would you like that bug fixed? Who wants it fixed in 120 days? What? Well, 90 days.
I'm good with 90 days.
You're okay with 90 days?
Yeah, I can take
So
90 days.
Shareef is okay with this vehicle being controlled by a nation-state actor, driven off and causing havoc within Portland, Oregon, I should state. Who wants it fixed within 4 hours? Yeah. As quick as we should be able to fix it, somebody should be able to hack it. That's the piece. So we have to have the tools within your team to really fix this. And to be honest, I want it fixed in an hour. Now, if I think about your background at Intel, my background at Wind River, together we were powering cell towers.
Yeah.
From Huawei and Ericsson and all of these. And no matter if you're Huawei or Nokia or any of these others, they had an expectation that we could patch bugs to the cell tower that was running in an hour. Otherwise, as they put it, a nation-state actor would take over. So if telcos are like, you got an hour, I think our 24 hours tending to 4 is probably reasonable.
Can we stick to 90 days?
No.
No? All right.
They said not.
And the last point is, I don't think, frankly, and Matt agrees here, and many at Ford, that this can be successful without a large collaborative ecosystem and lots of open sourcing in it. Like these large technology transformations happen in such environments, right? It cannot be done siloed. Each one can do it by themselves. There's something that we have to come together. And we see that VSS and COVESA is actually a very good platform to collaborate and bring it all together. Again, our objective as an OEM here really is to build those capabilities that enable rapid development cycle and expand the spectrum of innovation in ways that we can't tell today, frankly. We know where we want to be, but we also know that there is unknowns beyond that, and we want to achieve those. So, a key point, come on, all right. A key point here I want to touch base on, because I don't think we talked about it enough in this conference, and it ties very closely with all the bullets that we mentioned before, and that is virtual to physical vehicles, right? For us to be able to develop software, test it, deploy it fast enough, we can't do it on vehicles only. For us to be able to experiment with new use cases, right, or new framework, it can't be done on real hardware, right, because sometimes it's not there. Sometimes you're trying to figure out what hardware you want, so you want to do it on frameworks that are pre-hardware. And that's where simulation comes in. And simulation has a huge life cycle. It starts from a concept. I have an idea. I want to test it out, all the way to running full binaries on functional models and timing accurate models and be able to project performance and power consumption and whatnot, and validate your software to a point that you deploy the binary as is into a physical vehicle.
And that's not new in a way to automotive. We do that in the physical domain today. We've done that with CAE, with body panels for years. We've done that with Mill-Sill Hill for some of these systems. But I think the big difference is the speed at which Shareef and the team, the latency, the frequency that we're trying to do it at.
Yep. And how early we start with that, right? Because there's a big arrow here, right? It has multiple phases. Sill, Hill, and many other platforms are part of it, right? But there's also abstract ones, right? So level 1 all the way to level 4 and 5, and eventually to a deployed vehicle. And our objective is really to have those capabilities ready for our engineers and shorten this time as much as we can. So the way that you spin your software from a concept, like take the top level, I have this application idea, I want to test it, and go down the stack and the levels of accuracy, that should be very fast and very easy. So a developer should have those capabilities, be able to run them, spin off simulation, it works, it passes, it fails, I like it, I hate it, and move on to the next one. And why I'm bringing this point here, not because it only adds to the agility and to the validity of the system. You can do quality tests, you can run jobs here, thousands and millions of jobs in parallel, right? You're not limited to physical hardware. But it also, there's a very key point here where VSS actually enables us to do that better, because it provides a very good separation layer between application and the back end of it, right? Whatever is underneath that stack, it doesn't really matter at this point, because when a developer writes code and they do it using VSS APIs and taxonomy, I can start by returning true and false for that. Then I can attach it to the rest of the stack and run it fully with full binaries.
And that simulation is not just for Ford internally. We have to be able to share that with the rest of the ecosystem.
Yep.
So if you're working with us on a next generation ADAS system, if you're working with us on an existing ECU for ABS, we have to be able to share this cloud-native containerized set of simulations. And that's a big change from everybody bringing their software on a memory stick.
And I can share that day one now. I don't have to wait till I have an implementation behind it. I don't have to wait till I have system extracts and ECU extracts and everything behind it in order to give them what is the right CAN signal that you have to communicate with. Because I can give them an SDK. And that SDK can be invalid at day one, but then I'll update the backend of it when I have more data to back it up. But they can start writing their code and test it as the backend evolves. So that's a very key point that we see is a key for this transformation. Well, everybody knows this at this point, I hope. But this is the tree that really enables us to have this rapid transformation. This is where we see that this is a strength for us moving forward. We see that developing applications using SDKs that rely on this taxonomy is key. Moreover, we see that it's our obligation actually to contribute back to this. Because today VSS, right, it's built great for a specific set of capabilities, specific set of vehicles. Ford portfolio is much wider than that, right? And again, snowblowers, cherry pickers, upfitters, super duties, buses, you name it, right? So with these ones, they come with the different needs and different trees that has to be specified. And we see that, obviously we're not the only ones doing that, so there's a need for us to expand.
So yesterday we were talking about commitments, and there was a question from the audience about who's adopting this. Are you saying, as the chief architect for Ford, that Ford are adopting VSS and you're committing to upstream what we do and changes?
That's a very good question. Now, you dodged that question yesterday.
Well, I'm not the chief architect, that's you.
But yeah, for us, from our perspective, we see that this is a key point for our future vehicles. And frankly, I'm contributing to open source project is, I think it's something that every developer must do. If you're using open source, you should be contributing back to open source, right? And this is something that we're moving forward with also. There's no doubt about it, right?
I think that's the closest we're going to get to a yes, so
yes.
Thanks.
Yes.
There we go. Was that a yes to as close as we're going to get to a yes?
I can say it in 3 languages, by the way. So. All right. Key advantage of VSS, it hits many of the points. By the way, interesting thing here is that I joined Ford a year ago, right? And one of the first thing I found out is this COVESA thing. I didn't know Matt. I didn't know he's part of COVESA. I didn't know VSS. And I started looking at it. Actually, that digital auto thing, that's the first thing I started to play with. And I saw, okay, you can write this cool Python. I've been in software development for the vast majority of my career. And okay, you can write this cool Python. I like it. This is something we should take in. And then I found out that there's this dude at Ford that he's actually part of COVESA, and we made the connection and we started working together. But because the capability as it is today, it really solves many of the problems and really fits into the transformation pillars we talked about. If I don't have a nice SDK, if I don't have an API, clean, beautiful API that I can work with, I cannot be agile. It just can't be. I can't have fast, rapid development if I don't have a way to communicate with the car that is in very simple APIs. If I have to have hard-coded canned messages or whatnot, you can't be agile. It doesn't work this way. What do you think?
I think it's right. Yeah.
Where is it used? I think we've talked about it. OEMs, fleet managers, right? This is something that we see that this is an interface to a vehicle, and a vehicle at this point can be anything and everything that we produce. It can be, it's used obviously for communication also to the cloud and to the rest of the ecosystem where we started that diagram.
That's a really important point. Because data theory says you never want to transform that data. You will always spend compute cycles, which cost money, despite what the hyperscalers say, and you will always lose fidelity. So having that signal consistent throughout its lifespan is so critical. Now, at the moment, Ford I think we've got a fleet of about 12 million vehicles supported by autonomic for all of the different connected cars that we put out there. And then as well as that, in Europe and launching in the US, we have Ford Live for the commercial vehicles, where we have, again, all these different commercial vehicles looking at all of the different signals that we can extract from the vehicle to do prognostics, basically to keep that fleet time up as high as possible. So if you're using a parcel delivery van, you don't want it to go down for 5 minutes. You want to be able to predict exactly when it needs servicing, and you want to lower the total cost of ownership. We do that through amazing cloud solutions, and ultimately coming down to the data that we can extract from the vehicles.
Yeah, You want to learn about your driver's behavior. You want to learn about so many things in a very easy way. So that's the interfaces to a vehicle now are much wider than what we've seen before, and they're going to keep expanding. Do you want to take us through this one?
I can take this.
Go for it.
So ultimately, everything that we said is focused on our customers, be that in a transit delivering parcels and getting in and out of that door literally 400 times a day, or the Super Duty drivers that are hauling 40,000 pounds across 1,000 miles a day of the US, or any of the other car passengers. We've just announced and launched the Explorer EV in Europe, aimed at families who have an adventurous lifestyle. They all have a number of things in common. And the biggest one that we're finding now, no matter where you are, from buying the cheapest Ford Edge, the most valuable Ford Edge, we don't have cheap cars, we have value, right the way through to a fully loaded Lincoln Navigator, is their digital experience and their desire for their mobility, their vehicle, professionally and personally, to form a part of their life. And their demands on Ford, who they trust, for time back in the future when it comes to this L2 autonomy. Another reason we've just announced eyes on, hands-off L2 within Europe. It's actually active in the UK at the moment, looking to go and expand into these blue routes. So we're doing everything we can to focus on the data we need to understand the users in the cabin, and then what we should do with all of the cyber systems, all the physical systems in the car. And we're making, this isn't a disagreement.
That's actually a good point. And frankly, this is the first time I think I fully understand it. Because
no.
Yes, it is.
He lives 3 miles from me in Portland, Oregon, but we never see each other because one of us is out or the other.
We're never in Portland, Oregon at the same time. But you're never in Portland, Oregon. But that's a different story. No, our customers, no matter what vehicle they are driving, no matter how much they paid for it, there's the differentiation in features they receive. For example, if you had the lowest cost Ford Edge, you don't expect massage in the chairs, right? Let's be true. If you have the high-end Lincoln Navigator, then you do expect that massage in the chair, right? Not that you use it much, but you expect it. But all of the customers do expect technological experiences, right?
That's right.
They expect a stack that really works. They expect application on their phone that communicate with the vehicle. That part, it doesn't really matter. It became such a necessity. It's part of our life, and that brings us back to the phone example. It's like, no matter how much you paid for it, you expect things there that, when it comes to technology, to work and work well and provide you experiences that you didn't have there. Massage chairs, that's fine. I didn't pay for it. But no matter how much I paid, I expect technology actually to work.
And everything that looks and feels like it, all of the cluster, all of the graphics, it feels so much like what you get on your phone. Your expectation is based on the handset. Yeah. So Ford are making public statements regularly when it comes to our cellular V2X, our vehicle-to-vehicle, Matus, and the charging work. So we're really driving this ecosystem. And we recognize that hopefully Ford will lead. We're part of the thought leadership at Ford, but others will follow. And at times, others will beat us. And hopefully, through collaboration, through this entire mobility ecosystem, we can get to that next level. So our call to action is really proactive collaboration beyond the bounds of your organizations, at the levels that actually get the work done, that agile mindset that enables us to run faster. Think beyond the product. Think about everything that you need to get to a future world that we will have in our products with high-frequency updates and low latency between something changing, us coming up with an idea and be able to get it to market. That means that we need the mindsets, we need the tool chains, we need to share more than code. Code is not enough anymore. And then finally, optimize cooperation across the supply chain. Ford, for over 100 years, have recognized we build amazing vehicles, amazingly fast in mass production, through a really healthy ecosystem of software, silicon hardware and into the physicals of the vehicle through all the tier 1s, tier 2 silicon providers. That's not going to change, but we have to turn up the speed of collaboration. 10 years ago, Ford launched developer.ford.com, actually in partnership with an alliance. I can't remember that. Was it called Geneva or something along those lines?
Oh, was it? I didn't know that.
With Smart Device Link, where Ford said, we've got this thing that allows a phone to communicate with an in-vehicle system before CarPlay, before Android Auto. We need to go to the next level. We need developer.ford to help all these upfitters, everything in all these different domains in the vehicle. That's what we're focused on. But it can't just be about Ford vehicles. And that's why we're here today in Porto as a team with COVESA. Thank you.
Thank you.
Did we run out of time, or do we actually have time for questions?
We have time for one question.
Really?
Yeah,
I thought we had 15 minutes. All right.
yeah. We're
Somebody told us we had 45 minutes.
Yeah.
Oh, okay. That's not what the schedule says.
That's okay.
That's
We're fine with it. I'm sorry.
Let's run with it.
It's about being agile, right? It's like
Let's
We're
run with
agile.
it.
the schedule.
One question? No questions is okay. Thank you so much. Have a great day.